Welcome back, Honors Algebra 2. We are going to continue on with 6-4. I know 6-4 is just like a massive, massive section. So that's kind of why I broke it up into 2 days for us. But we are going to get started. So you just start continuing on with 6-4. It's like no new title, no new nothing, just still 6-4. So we're going to start with coterminal angles. Coterminal angles, so angles in standard position with the same terminal side. Oops, not ready. Are coterminal angles. So examples of coterminal angles, because I know a lot of you guys are like, well, what does that mean up there? Examples of coterminal angles. So a coterminal angle to 0 degrees would be 360. Now, what that means is if I were to, okay, some of you guys skateboard, right? And when you do a 360, excuse me if I sound like an idiot, but when you're like doing a 360, that means you like spun around and landed exactly, maybe I should be like doing this, but like you spun around and you landed exactly where you started. And so that was a 360 degrees. But even though you're landing exactly where you started, you still went around a full circle. Now, another coterminal angle to 0 degrees and 60 degrees would be a whole other rotation, would be 720. Now, it doesn't always have to be positive. So if I start here and I go 360, 0 and 360 is still, at the same spot. But if instead of going in the positive direction like that, and I go in the negative direction like that, it still lands me in the same spot. So another coterminal angle to 0, 360, 720 is negative 360. So coterminal angles are basically angles that are in the same spot as like another angle. It's just like 360 more or 360 less, or 2 times 360 more or 3 times 360 more, whatever. So because this can really keep going. So to find a coterminal angle, add or subtract either 360 degrees, or if we're dealing with radians, 2 pi radians. So for number 1 through 4, it's asking us to give 2 coterminal angles for each given angle, 1 positive and 1 negative. So all we do is to find a coterminal angle of 65. Now, if we were thinking about where is 65, like on our like grid, 65 would be, I don't know, like if we were to start here, 65 would be maybe like there, right? So to get another coterminal angle, we'd go from 65 and add a 360 rotation. So to get 1, we would just do 65 plus 360 to get me 425 degrees. So 425 degrees, if I went 425 degrees, I'd be going 360 plus another additional 65, which would land me at the same exact spot. Now to get the negative, it would be 65 minus 360, which is negative 295. So negative 295, that means it's going negative 295 this direction, and it lands me right there. So those are my 2 answers, 425 degrees and negative 295 degrees. Now I could keep going. I could add 360 to 425, and that would get me another coterminal angle. trying to get my calculator because, oh, there it is. Or you can like keep subtracting. So if you did, and like again, 425 plus 360, 785 is another coterminal angle. If I added 360 again, 1145 is another coterminal angle, and so on and so on and so on. Okay, so what I want you guys to do is try number 2, one positive, one negative. This one's a little bit different, but you can try it, or if you want to see me do it, you can just wait now and I'll do it right now. Okay, so 540, we know that's bigger than 360. So to get one positive, you can add, you can subtract 360. It really doesn't matter. Either answer would be correct. But what I'm going to do to kind of help us now, I'm going to go 540 and I'm going to subtract 360. And so 540 minus 360 gets me 180. So 540 and 180 are coterminal angles, which means, okay, we know where 180 is on my graph. 180 is over here, right? So that means 540 is 180 plus another whole 360 to get back there. Now, if I wanted to find a negative coterminal angle, well, what I can do is take 180 and subtract 360, and that's going to get me negative 180. And so 180 degrees and negative 180 degrees are coterminal angles. Now I'll show you on the graph. So negative 180 is starting here and just going in the clockwise direction. So negative 180, this is negative 90. This is negative 180. It lands exactly where we started. If I wanted to go and keep going, I could do more coterminals with 540. I could add 360. 900 is another coterminal angle. Keep going. 1260 is another coterminal angle. So these are all they're all ending at this point. Okay, so 3 and 4 are both in radians. So what that means is we need to use 2 pi instead of 180. So I am going to take 13 pi over 18. And I'm going to add 2 pi. Now, here comes fractions. Now, I would just in here, I would get a common denominator, put this over 1. Common denominator between 18 and 1 is just 18. Oh, that was a weird parentheses. And so what that is it's just giving me 13 pi over 18 plus 2 times 18 is 36 pi over 18. Same thing, right? And so then we just add 36 plus 13, and that gets me 49 pi over 18. So 49 pi over 18 and 13 pi over 18, if we were to convert those to degrees, those would land in the same exact spot on our graph. Now we're going to do that. I'm just going to box this one because I'm not going to have much room here. Now I'm going to do the same thing to get my negative. I'm going to subtract. So 13 pi over 18 minus 2 pi. Again, we have to get that common denominator. And so we're going to be doing 13 pi over 18 minus 36 pi over 18. And 13 minus 36 gets me negative 23 pi over 18. Notice how I ignore really the pi. I treat the pi almost as if it were an x, as if it were a variable, and these have variables on them. So I just deal with the coefficients, and that's all that I'm doing there. Okay, So 14 pi over 9, 14 pi over 9 is actually bigger than 2 pi. The way that no, I take that back. I feel like if I could like do like a reverse, I would take that back and like rewind it, but I haven't figured out how to do that with the technology yet. So I'm still working on it. So 14 pi over 9, if you guys want to try it, it's just like number 3. I was thinking it was like number 2, but it's not. So it's just like number 3. You guys can do it on your own. Come back, try it, or make sure you guys did the right work, and then I'll do it right now with you. So we are going to do the same thing we did over here. 14 pi over 9, we're just going to first add 2 pi. And just to like let you guys know, the reason I knew that this wasn't bigger than 2 pi is because 9 goes into 14 less than 2 times, right? If it was bigger than 18, I'd know it'd be bigger than 2 pi. So if I were trying to get like a positive and a negative, I would do something like this. But it's not, so we're good. So I again have to get a common denominator here, 9 over 9. And so that's going to be 14 pi over 9 plus 18 pi over 9. So 14 pi plus 18 pi gets me 32 pi over 9. 32 pi sounds so good. I'm hungry, apparently. Like a really good, what kind of pie sounds good? I feel like key lime pie sounds really good right now. Okay, so now once we've gotten the positive, we can now get the negative by subtracting 2 pi. So we're just going to go through that same process again. See, I can still have my like random tangent conversations with you guys. It's just no one responds to me, which is kind of depressing, but I feel like that's what my 2 weeks has been. It's just been a lot of talking to myself. But that's cool. I'm entertaining. That's all that matters. Okay, so we got a common denominator because you have to get a common denominator with your fractions. So 14 pi minus 18 pi is negative 4 pi over 9. And so you have your positive coterminal, your negative coterminal. Remember, no matter what, those are both at the same spots. So they're at the same spots. Everything is the same. Those are coterminal angles. Okay, so number 5 and 6 is saying find the exact value using the coterminal angle. So if you notice 9 pi over 4, 9 pi over 4 is greater than 2 pi. I know that because 4 into 9 is more than 2. So in both of these examples, they're greater than either 2 pi or 360. So when the angle measure is greater than 360 degrees or 2 pi, basically subtract just like we did up here. Subtract 360 or 2 pi until you get something. I should say actually subtract or add until you get something between 0 degrees and 360 or 2 pi, depending on like if we're in degrees or radians. So that's essentially what I'm meaning by that. So when the angle measure is bigger than 360, so let's look at this one. It's bigger than 360. Well, we don't know what the like cosine of 390 is. So what we want to do is first find its coterminal angle. We want to find what it is in between 360 and 390, or I'm sorry, in between 0 and 360. So what we're going to do is first like apply what we did in 1 through 4. We're going to find the coterminal angle. And so I'm going to start with number 5, and I'm going to first find out what the coterminal angle is. Okay, so the coterminal angle of 9 pi over 4, so we know that's greater than 2 pi, so I'm going to just subtract 2 pi from those. Now, in my head, like I get a common denominator in my head. Like I just, like I can think about, okay, 2 pi, to get a common denominator, we're going to have to multiply top and bottom by 4. So it's going to be 8 pi over 4. If you need to write that out, totally fine. Do what you need to do, right? So 9 pi minus 8 pi is 1 pi. We don't have to write that. So pi over 4. So sine of 9 pi over 4 is going to get me the exact same answer of sine of pi over 4. And now you're thinking, wait, I know how to do that because I've already been doing that. Sine of pi over 4 is the same as what angle measure? Well, hopefully you're saying it's the same as 45 degrees. So if you want to write the sine of 45 degrees, all of these are going to get you the same exact thing. No matter what, gets you the same answer. So I'm going to draw my 45 degree angle. One, rad 2. Now, just to like switch it up, I'm going to look at this 45 because it really doesn't matter. I can look here. I can look here. Both my opposite and my adjacent, no matter what angle, are always going to be 1. So my opposite here is 1. My adjacent is 1. My hypotenuse is 2. So the sine of 45 is opposite over hypotenuse. So that's going to be 1 over rad 2. We have to rationalize my denominator. So I multiply top and bottom by rad 2. And 1 over rad 2 is just rad 2. And rad 2 times rad 2 is 2. So that's actually my final answer. So the sine of 9 pi over 4 is equal to rad 2 over 2. And that is your answer. So as we're going through this, and if you guys have any questions on any of the problems, please write it down, write it on a Post-it, come to the Google Hangout, ask me in office hours, email me. Like if you guys are frantic and you need to email me, I'm always going to respond to you guys. I typically try to turn off my computer at 5. So just bear with me if it's in the later hours, but I'm always trying to be on like between the hours of at least like 8 and 5, to support you guys in whatever you guys need. So ask away. Okay, so with number 6, what I want you guys to do is first just figure out on your own what's my coterminal angle. So if you need to pause me and come back, that's fine. If you're like, I figured it out in my head, that's great too. So my coterminal angle, we know 390 is greater than 360. So I'm going to subtract 360 to get 60 degrees. So 60 degrees is at the same spot as 390. So that means that the cosine of 390 is going to be exactly the same as cosine of 60. And we know how to do how to find the cosine of, I had poor math. Again, why is this video the one video where I need to learn how to like rewind myself on these videos. I know there's a way, but like, let's be honest, I feel like sometimes you guys just enjoy my mess ups and then I catch them. At least I catch them. So my subtraction was really poor there. 390 minus 360 is not 60. It's definitely 30. And so cosine of 390 is going to be the same as cosine of 30. I really I miss you guys like yelling at me and telling me when I've made my mistakes because, you guys keep me on it. Okay, so what I want you guys to do is try this one on your own. Cosine of 30 is what? What is cosine of 30? You guys know how to do this. Use your special right triangles. Pause me here. Do what you need to do, and then come back to check your work when you're done. I'm going to take a sip of coffee to make sure you pause. Okay, so hopefully you're coming back with some work. And you drew your special right triangle. 30 is the top one. It's the smaller one. And so 1, rad 3, and 2. So when we're looking at 30, the opposite, the adjacent, and the hypotenuse. So cosine is adjacent over hypotenuse. So that's just rad 3 over 2. So that means that cosine of 390 is rad 3 over 2. And that's your final answer. Hot diggity dog. Almost through with this one. Okay, so we talked about coterminal angles. Coterminal angles are basically when you're adding or subtracting 360. A reference angle is very different. A reference angle is an acute angle. And hopefully you guys are remembering what an acute angle is from geometry because your geometry teachers helped you so much with that. You remember that an acute angle means that it's less than 90 degrees. So a reference angle is an acute angle formed by the terminal side of an angle and the x-axis. So that means that you are always going to be wherever your angle is, and I'm gonna try and draw this as much as possible and visually show you as much as possible. But you're always gonna be bringing your angles back to the x-axis. So if we kind of look at our grid here, we know this is 0 degrees, 90 degrees, which 90 isn't on the x-axis. 180, which is 270, and 360. So when it says is formed by the terminal side of an angle, so wherever the angle ends, and the x-axis, we're going to be creating new angles by bringing it always back to the x-axis. Okay, so that sounds really weird, but we're going to do some examples. Now, also, not to I'm going to front load you with some more information. A reference angle will always be positive. So a reference angle will always be positive, and a reference angle, because we know that it's acute, the angle will be less than 90 degrees, or basically between 0 and 90. Between 0 degrees and 90 degrees. So we're going to be using reference angles a lot. It's something that really plays into next year too. When you guys get into trig next year, it's huge. It's just something that you guys see over and over and over again. So, so we're going to start with finding those. So just, follow me along, and then we'll hopefully you'll be able to get it. So find the reference angle for 205 degrees. So the first thing I'm going to do is figure out where 205 is. Okay, so I know it's not in quadrant 1 because quadrant 1 is 0 to 90. I know it's not in quadrant 2 because it's 90 to 180, but I do know it's in quadrant 3 because quadrant 3 is 180 to 270. So 205 is somewhere like here, right? So that is going to be 205. So 205, what it is, so a reference angle is an acute angle formed by the terminal side. So this is the terminal side and the x-axis. So we're going to bring it back to the x-axis. And so how we find that amount, we brought it back. What's the closest x-axis? Is 180. So what we're going to do to find this distance of this angle is we're just going to do 205 minus 180. So 205 minus 180 is 25 degrees. And that's the reference angle. So a few things. First, I went back to 180 because if I went back to 360, and I'm going to show you guys on your calculator because really those are the only two options you can do. If I went back to 360, 360 minus 205 is 155. And remember, a reference angle has to be between 0 and 90 degrees. Now, if I went back to 0 and I did 0 minus 205, it's negative 205. A reference angle has to be positive. So you really have only two options, 180 or 360 of what you're going to subtract. And so we subtracted 180 because it's the closest x-axis value. So let's look at 2 together. So 2 is 310. So again, I'm first just going to draw that out. Where is that going to be? Not in quadrant 1, not in quadrant 2, not in quadrant 3, but it is in quadrant 4 because quadrant 4 is 270 to 310. So that's going to be about, I don't know, here. And so I think, again, what x-axis is it closest to? Is it closer to 180 or is it closer to 360? And it's definitely closer to 360. So remember, again, we're always going back to the x-axis. So you're never going to be going to 270 or 90. That is not an option. And so we're going to subtract. 360 minus 310 gets me 50 degrees. Now you may be thinking, how do I know when to subtract it from it or subtract from the either start with the 205 or start with the 360 or whatever. You just have to know okay, for one, you're always going to the closest x-axis, and two, it should always be positive. So whenever you're going from 360, you're always basically going to be subtracting from 360. Okay, so let's try 120. So 120. And if you guys are feeling good and you feeling confident with it, what I want you guys to do is try 3 on your own. But if you want me to do it with you, then that's fine too. So I'm going to start by drawing where 120 is. So 120 is not in quadrant 1. That's 0 to 90, but it is in quadrant 2 because that's 90 to 180. And so quadrant 2, it would be about there. I don't know. I'm not good with my guesstimates. And so then we're thinking, what is the closest x-axis to 120? Is it going to be 180 or is it going to be 360? And hopefully you're saying it's 180. So then I just do 180 minus 120. See, there's a switch up from this one too. Okay, 180 minus 120. When it's like, it has to still be positive. So no matter what, it's still positive. So you just have to kind of like logically think. This one was more than 180, so we like subtracted 180 from 205. This one was less than 180, so we subtract 180. No, we subtract 120 from 180. So 180 minus 120 is 60 degrees. Okay. So now we have something a little different on 4. We have negative 330. So it's a negative answer. And we haven't had one of those before. So what I'm actually going to do before I do anything with reference angles is I'm going to get the positive coterminal angle first. So I would first get the positive coterminal angle. So bringing it back up to the start of the notes. So to get a coterminal angle, remember coterminal means we're adding 360. And so negative 330 plus 60 is 30 degrees. But wait, 30 degrees is already an acute angle and it's positive. So we don't actually have to do anything. That is my reference angle. 30 degrees is the reference angle there. So I'm going to pause the video here. Again, please bring like your notes or anything to office hours that you guys need help with, and I will finish the last page on the next video. So I hope you guys, take a break here, go get a snack, I don't know, go watch a TV show, read a book, draw a picture, and then come back for part 2 of or part 4, I don't know, whatever part we're in or you're feeling like it is, come back for the next video. Okie dokie.